Hello? You guys hear me back there? Okay. So we may have some stragglers coming in, but I want to welcome you here this morning. I'm Doug Casey. I head up the State's Commission for Educational Technology. And I just wanted to make a quick note of introduction of our speakers. We've got a great program in this session. I think you're going to enjoy it a lot. Our first speaker is Tim Brzezinski. Tim informed me that he had to leave because he's got to go teach. He's got a day job. He's a teacher at Berlin High School, as well as the founder of Dynamic Math Solutions. They're the makers of GeoGebra, and he's going to talk a little bit more about that. In his day-to-day teaching, he regularly teaches technology that promotes active, hands-on, student-centered, discovery-based learning. He's authored a number of lesson activities that engage students to think critically, formulate and test conjectures, and construct new knowledge based on findings in his free time. He enjoys quality time with his wife Ashley and his two children, Noah and Elijah. So without further ado, I'm going to welcome Tim to the podium.
Thank you for having me. It's an honor and a privilege, but I got to make one correction. I did not invent GeoGebra or create GeoGebra. It's a free app, like Google, has Google Docs, Google, Sheets, Slides is their version of PowerPoint. You know what I mean? So it's funny how a lot of people today, I always find it ironic. It's like, if I asked you, would you prefer to type a book report using Microsoft Word or Google Docs? Most of us in the room will probably say Word, right? Because it's what we're used to. A lot of us will pay the $150 for. Can you hear me? Am I loud enough? Yeah. A lot of us will pay the $150, to buy the Microsoft Office package, right? But when you could literally have a Chromebook act as a PC, even though it isn't really, right? But you got your docs for Word, you got your sheets for Excel, you got your slides for PowerPoint, right? So, and a lot of our kids, every kid at Berlin High this year has, we received the grant, I guess, from the state of Connecticut because we were one of those pilot SBAC testing districts, like, before what states and law will do away with it. But we were actually one of those, and we got a lot of grant money from that, from which now every kid, we bought like all these Chrome labs, all these Chromebooks. Every kid has a Chromebook, and it's cool. So therefore, in any kind of like math class I have, I have hundreds of applets on the internet here, and I'll show you them. But it's like you can actually have the kid open up a Chromebook, interact with something, meaningfully, and have them tell you what they see. Because a lot of times the problem in math education is that we teachers, we tell kids way too much. We tell them too much. We don't give them the opportunity to think for themselves and actually tell us what they see. So if you have your iPad, you have your computer open, strongly encourage you to go to this link here. I'm going to show you a place where you can actually steal. It's like I feel like a used car salesman because everything is free, right? The Google platform is free, but GeoGebra is currently right now is the world's leader in dynamic mathematics software. All right, I know we have Desmos, we have TI, there's a lot of others, and we have stuff like Wolfram Math, but they're more computational, like, information storage engines. But GeoGebra literally was designed by a man named Marcus Honenwerder back in like 2001. And he did it as part of his doctorate, to his research, his dissertation, whatever. But he actually, when he wanted to create a virtual platform that would be free, to some school districts in Europe, because he was in Austria at the time doing his research. And he literally, he came up with this, and all of a sudden it just took off. And he had no clue that it would become this world famous and worldwide. And currently he's a visiting professor at the University of Florida, but they're always they've had, since 2001 and 2002 when GeoGebra came out, since then they've got like 5 new versions, and every version is better. They currently have a 3D graphics version. You can actually take a plane slicing a sphere in 3 space and look at it from any angle you want and see cross sections, intersections. So talk about kids in higher level calculus having a hard time seeing solids of rotation. GeoGebra provides such a cool way, and it's a free way to see all this stuff. And part of what I do in my business, Dynamic Math Solutions, I go out to school districts, I create materials for publishers that they can use to supplement, courses, but also to empower teachers within the classroom too. So if you can go to the web here, I suggest Chrome because I find Chrome works the best with GeoGebra. Unlike, there are differences between, say, Microsoft Word and Google Docs, right? But the beautiful thing is with GeoGebra is that you can use it in the online app form, or you can actually download it for free to your desktop, your Mac, your laptop, iPad, whatever. If you have an Android, GeoGebra just released the graphing calculator thing. I think Apple's, the App Store for Apple is very, they're kind of more picky about their apps. Anybody can make an app and put it on Google Play, right? But math is pretty fussy about their apps, So I believe it'll come out in a year or so. But regardless, it's a cool thing. So what you want to do is go to tube.geogebra.org, T-U-B-E, okay? GeoGebra.org. All right? And this is like the YouTube, if you will, for math applets. All right? And just like YouTube, there's a lot of crap out there, but yet there's a lot of great stuff too. But with GeoGebra Tube, it's kind of the same thing, but they've gotten better. A lot of their they have some featured materials up here from people in the GeoGebra community that contribute all the time. But these are all free resources here. I mean, this was, I see some people, you can actually take people's stuff and recopy and do whatever, but I'm going to ask you where it says search materials. Check it out. Let's just type in the letters T, J, actually before you do that, if you want to, I'm going to show you how to create your own account for free. So if you go to sign in, right in the upper right hand corner, this will take like 2 minutes. All right. I would recommend signing in through your school email, but if you just sign in through Google, if you have a Gmail account, it takes 2 seconds. And when you create your own account, you say, well, I want to, even if you click, I want to receive occasional newsletters, you'll get 1 email a year pretty much. They don't spam you at all. All right, it's cool. But you can go ahead and sign in, through Google or whatever. So if you just take a minute to go ahead and do that, because what I'm going to do, especially if you are a math teacher here, if you like anything you see, I'm going to show you how to literally take it and add it to your personal stash of files. You can have your own filing system. You never have to upload an applet to GeoGebra Tube in order to use the stuff that's on GeoGebra Tube. You can find high quality materials for absolutely free that you can use within the mathematics classroom. Okay? And so that's why I'm having you do this right now, if you will. So I'm just going to sign in as me here. Give me a second. Okay. And if you sign in, you should see, you should literally see like you should see like a picture of a silhouette up here in the upper right hand corner. Do you see that? Once you create your account and sign in, you don't have to put any biographical information on there. It's nobody's business, right? No one's going to be looking anyway. But basically, you'll see if you go up here, you'll see like a silhouette up there. I mean, I put a picture, of course, but GeoGebra has. These are all the resources. These are all my personal creations here. But in essence, you could use it to help kids discover certain things. For example, let's go to in search materials. Just type in the letters TJB. Okay. And you will see it says TJB GeoGebra Sampler. It's got 2 triangles kind of crisscross in there. If you click that one, all right, that'll take you to the book. This is what we call a GeoGebra book. It's basically got a ton of, it's basically like a huge file folder, if you will, that's got a gazillion applets. So you could break them up into different chapters. Teachers, I've seen teachers do this, but this is one I use when I give a general talk like this. But I just want to take you through just a really brief introduction of why GeoGebra is such a great program. But if you go into this chapter 1 where it says triangle 1-1, where this thing is triangle angle theorems, go ahead and click on that. Okay? And notice you'll just see an applet load up here. It just has a virtual triangle. Now I'm going to challenge you here. I want you to move those vertices, those corners around the triangle anywhere you jolly well please. So go right ahead if you dare. You can make an obtuse angle, whatever. Move those vertices anywhere you want. And then after that, I'm going to ask you to slowly slide the slider that says slide. Okay? And for those of us here that, I promise I won't call on anybody. Whenever you hear the math talk, people always get nervous. Oh, shoot, he's crap, he's going to call on me, right? But tell me what you see here. In the 3 interior angles of a triangle, what do you notice? Yeah, they out to 180 degrees, right? Well, and let's put that to the test. Now, I personally believe that doing that on paper and pencil is way better. You cut out the triangle, right, and you rip the 3 angles off, you can form a straight line there. But the cool thing is that when I'm in a math support class where you have kids that are like, duh, dude, how can you not freaking remember this thing? We just learned this yesterday, right? It's like, you know what, I don't tell kids crap. Mr. B, I don't remember. And I say, you know what, I said, get out your Chromebook. And at this point, they crab at me because I make them take out their computer because why? I'm putting the responsibility of learning on them. That's what GeoGebra allows you to do. Any kid in any math class that forgets the angle measures of a triangle at 180, they're going to revisit this applet right here, and they're going to tell me what they see. I love these informal proof without words concepts because, notice, there's no angle measures here. It's all pictures. Yeah, the picture menu at McDonald's is easy to read. Well, this is like a picture, but the thing is, it requires the kids to go a little deeper. And for high, you can differentiate for high level kids. Well, why? I mean, how do you know, for example, that when you slide the slider right here, right, that line is parallel to, like, this angle equals that. Well, when you rotate about the midpoint of a segment, there is a Euclid postulated that, you know, prove that you actually create a line parallel to the original line. So you could visit other theorems here. Hey, alternate interior angles are equal when lines are parallel. So the whole point is this can be used to discover. If you're out of time, let's suppose you have a PPT to go to in prep. You know, I've got to get the kids busy work. Let them play with this and figure it out. You know, that's the cool part about it. And now, even for the exterior angles, right? This is what we talk about, like dynamic mathematics software. I mean, something like this is pretty easy to create, but you can literally take this and move the slider, and the exterior angles add to how much? How many degrees in a circle? We all know 360. So the exterior angles of a triangle add to 360. Well, is it true for every triangle? Well, heck, let's move it around and see, right? Yep, there you go. Okay? Now, if you fell in love with this app, but let's say you like it, and you want to add it to your stash. If you're a math teacher here, you can create your own personal file stash here. So if you go see the 3 dots in the upper right-hand corner, all right, usually when I do this intro session, it's a 2-hour session, but we're condensing it in a half hour, so I apologize if I'm going a little fast here. But just go here. If you go to the About, right there, you will see, you know, all different things. But what you can do is click Add to Book right there. Just click the icon, add the book. Now, I have like 40-something books here of all my stuff, but you have none since you just created your account. But do you guys see an icon that says Create Book or something in there? Go ahead and create the book and call it maybe Geometry Applets or something. You know, you can do your own filing system later if you wish, right? But you can actually just create the book and I can add it to, you can add it to as many file or books as you want. I'm not going to add it here, but you can, you know, for whatever purposes of organization you have. All right? I know this is a technology conference. You guys are pretty tech savvy. You can figure out how to make chapters in the book when you go. I mean, that's, you know, it's kind of like the, yeah. All right, trying to teach Einstein physics. So you guys can definitely figure that out. But so that's kind of what it's used for. But and in this sampler, I'm not going to have time to show you every item in the sampler page here. But the point is that GeoGebra I use all the time to discover. Like you can use this applet to discover. You can use this applet to provide remediation. You can also use this applet to differentiate. I'll give you an example. If you want to open a new tab here, I'll show you the app itself. If you go to just geogebra.org, that's their main site right there. And you have 3 big tabs here. You can download it here for absolutely free to your software. I talked to my school, the IT guy at my school, Berlin High, said, could you please get this on every laptop? And yeah, it was done in 5 minutes. Totally free, high quality. All right? The Start GeoGebra is the actual app. Now, if you click Materials, that takes you back to GeoGebra 2. All right? But let's go to Start GeoGebra here. Just want to show you something really quick because I know I don't have much time. But GeoGebra has 6 different perspectives. Algebra, geometry, you can read them all. But let's just go to the algebra perspective here. Note, how many of you use Desmos at all? Desmos, you familiar with it? All right, now I'm not here to put Desmos down. It's a great app. I love it. But GeoGebra can do what Desmos can do, but it can do a lot more. You know, with GeoGebra, you can put buttons in there. You can put sliders. Desmos has sliders. You can put input boxes. So I'll give you an example here. It's just a couple basic things. All right, if you go to, let's say you go to the polygon tool, just click the triangle. All right, and let's just, you know, point, and then to close it, you just got to go back to the one you started with right there. So I have a polygon, you know, with sides A, B, and C right there. Now notice that in the algebra menu right here, this is a list of all the objects here that you have in this window, the geometry window right here. Okay? So now, one assignment I gave my kids over the weekend, I said, I tell you what, my geometry class, I said, I want you to make 6 different applets, and you're going to upload them all to GeoGebra too. Kids can do it, it's easy. All right? And I'll show you how to upload an applet too if you want. But what I want you to do is measure all the angles here, and I want you to add them up. Okay, and show me the dynamic text that does that. So see how the whole difference is? When we were in school, most teachers were like, hey, Johnny, let's open up your brain and dump some knowledge and blah, 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 blah. And some of you fell asleep in math class after the teacher took his or her first breath, right? But here, it's a whole different ballgame. Their learning is now on the kids. not on you. I'm the facilitator of learning. You guys, you facilitate the discovery. So the kids, and I can show you one of my students' examples here. I'll show you after. But what I'll do is let's just go to the angle tool here. I'll go to angle, and I'll just click the polygon, and notice how the 3 angles come up. Okay? And with those angles, I'm going to, just save time here, I'm going to make all those angles stay between 0 and 180, because if I move the vertices around, they might, you know, it's hard to explain, but right here, see the angles are pretty much right here. You can see them. I know you can change the colors, you can do whatever, but I'm just doing a quick session. But now the kids will go here and say, okay, well, I want to show some dynamic text here, show Mr. B what I discovered. So here we go. Let's see, so I'm going to take, in this menu here, all right, I'm going to say, you know what, if I take this angle, it's down here, alpha, and then I'm going to add plus, I'll do beta, plus gamma, okay? But oh wait, I'm going to go back to this input bar. I should actually add them up. What do those angles add to? 180, right? And so I could actually add them on my calculator. I'll do it here on GeoGebra quickly. Let me see here. So let me go here and I'll just say, this one here we go. So, and these are, see these objects here, the objects in the GeoGebra platform. But alpha, oops, I'm still in that text there. But there you go. I mean, I'll make that a little bit bigger so you can all see it there. Very large, say. All right. But the cool part is, right, no matter what, I mean, I could have GeoGebra do the adding, but notice here the text changes as the kids move the triangle around. I mean, what I did, I know I did it fast, but it's very, very easy to learn. Like, I mean, and this is on the online app. It's a similar way in the actual software. See, this program I love so much because the app is just like the software. Yeah, Microsoft Word and Google Docs are like, they're kind of similar if you do the basics on it, but there are differences once you get to the advanced things. But even with the advanced stuff here in GeoGebra and the advanced stuff with the software versus the app, they work pretty much just the same. All right. So now a kid will take this and they'll just say, hey, you know what? I'm just going to put, just to save time, I'm going to edit this text here. Right click, object properties. Anyway, I'll just put, no, okay, here we go, and I'll just put a, I just got rid of it. But basically, at the very, very, very end, I put equals, 180, even though this equation is wrong, but I delete it. But notice here, it's just, this is what I've discovered here. And so to upload that applet to GeoGebra Tube, I would literally go here and go to save, right? If you want to do this, and just call this triangle, angle, theorem. And then to save it, if you want the whole world to be able to see it and access it, you make it public. All right? If you want to make a private file to share only with a password, you can do that. But you can also have a shared file, but you got to provide someone with a private is the only thing you can see. Like say it's a project you're working on, you don't want the world to see it, whatever. But a public, a shared one is like you have to have a separate password to get into the thing, so you have limited access. But a public is anyone in the world can access it, whatever. But then if you make it public and go back to GeoGebra Tube, it literally will be there, in your stash of worksheets. When you go back to GeoGebra Tube, you will see that up there. Now for the heck of it, I'll just put it there, even though I wanted to. But public, I'll hit save, right? Now watch this. I'll go back to GeoGebra Tube materials, and there it is. See triangle angle theorem right there? It's the next one on my cube. It's kind of like the iCloud storage, and guess what? I can take this, and any kid in the world, I could take the link to any app that I create and upload it to Schoology or Google Classroom or whatever virtual platform that your school may happen to use. But GeoGebra allows you to simply, I'm going to delete this one because it's wrong, because I'm only adding 2 angles, not 3. So if you want to delete it, just click delete. You can delete whatever you want. If you want to copy somebody else's thing, you can. You just go to About, Make a Copy. And you can call it yours. You can change the directions in that applet the teacher wrote, whoever created the applet wrote. You can do whatever the heck you want, right? But you're still giving credit to the original author. So like, for example, if I go to GeoGebra Tube right here, I could find, I'm just going to show you, but the whole point is that GeoGebra allows you to do this and a lot more. And it's used, trying to squeeze in a half hour, what I can say here. They also have a community, we're a part of the GeoGebra community. It's open education resources. It's all free. You can write, I have lessons that go with a lot of these pre-made applets here. For example, let me give you a quick example about discovery and differentiation and assessing all at the same time. If you go to the sampler right here, the same TJV one, I think it's in the second chapter called differentiation here. Go to number 4, it says parallelograms. I'm going to show you something. So these applets here, right, once it loads. These applets here, again, virtual. I could have a kid put out a parallelogram, but you know what? If the kid was out sick the day, see, in honors geometry class, for example, I would have the kids discover properties of parallelograms by making their own parallelogram on a blank template, right? They can measure opposite sides and see if they're equal no matter where I put the vertices. They can measure opposite angles. Oh crap, they're always congruent. That's freaking cool. And they can see that the diagonals bisect each other, right? But let's suppose a kid's been out sick for 2 or 3 days. I'm not going to have them go through the lab again and, like they're going to take forever to catch up. I'll take that kid, give him the same assessment questions on parallelograms. I'll say, here, I want you to play with this for 5 minutes and then see if you can tackle the same warm-up questions that the kids who were in class yesterday that went through the lab to build it themselves did. And so the kid plays with it, right? And all of a sudden they have, oh, okay, well, even though this does not constitute a formal proof whatsoever, check it out. What are we showing? Opposite sides of a parallelogram are what? Equal, right? Or it's congruent, right? And what about over here? You can actually take it and show that, well, you got a parallelogram, again, virtual, modifiable, but now I'm showing that angles that are opposite each other are, oh wow, yeah. I love the sliding action there. But opposite angles are congruent, right? And so here's the question, 2x plus 3, 8x minus 5, oh, I have no clue what to do. I tell the kid, okay, here's a remediation setting, right? Go play with this applet, you tell me what to do now. I ain't telling you squat. And that's what I mean by putting learning on the kid. That's what we have to be doing, I believe, as teachers. GeoGebra is an awesome way to make that happen in a matter of a second. And it's all about knowing where your GeoGebra stuff is and what you have available, whatever. Same thing with the diagonals with parallelogram, right? And notice how, any of you using the Connecticut Common Core, like geometry, model geometry curriculum in your schools at all? Like the Common Core standards place a huge emphasis on transformational geometry, that is rotations, like dilations, reflections, that they preserve angle measure, not, dilations don't preserve distance. But basically here, right, for the diagonals of parallelogram, if you scroll down one more, if you draw one diagonal, right, and the other diagonal, they cut each other in half, and rotation preserves, So yeah, I could put the numbers there if I wanted to, but why? If I can make the kid think a little more deeply about what they're seeing. I could put all the reds 10.8, 10.8, and the blues 4.2, 4.2, but yeah, that kind of gives it away to me and still, but here it's still like, it's putting the learning on them. Tell me what you see. And a reminder, wow, rotation preserves distance. Oh, how many degrees did it rotate? Higher level questioning now. GeoGebra gives you the opportunity to do that. Now, to make something like this on paper, is it worthwhile? Yes. I'm not all technology and no paper. I believe cutting out shapes of paper, especially for the younger grades, tactile learning, that's so important. We don't want to, we hear all the case about these iBabies and whatever, but reality is technology is a huge part of our lives. Why not use it? And I hear teachers crapping all the time, these kids are playing video games, right? But I'll tell people in my department, I said, listen, you know what? If they're motivated to use the technology, why not have them get excited about doing it by making their own applets? By uploading them, by whatever, and say, look, you can share stuff with the world, It's really, really cool. So this is what I do, by day I'm a high school math teacher at Berlin High School, but by night, or by whenever I have free time, I guess I don't sleep that much, but I founded a company called Dynamic Math Solutions, and this is literally what we do. I love to I've gone to districts, I do workshops for, I'm doing workshops for districts in New York State this summer. I'm heavily involved with the creation of of over like 80 to 100 applets for the new Common Core Model Geometry curriculum coming out, a new version of it coming out this June, and we're going to have a conference on it at CCSU June 21st. But I love GeoGebra. It enhances math instruction so much, I think, and it's all in how it's used. I have over 300, plus applets, very similar to the ones you've seen for almost every third in geometry. A lot of algebra, 1. I'll show you something really quick again here. I don't have time, but geogebra.org. Right? Whoops, wrong URL here. All right, like linear equations, right? Y equals mx plus b. But what the heck is m? What the heck is b? Like kids. We teachers oftentimes will teach it way too abstractly, but I'll have the kids play around here for a little bit. Say, okay, and some of you may have seen this activity similar to that done on the TI or done whatever, but let's just go into the input bar and literally type that in. Okay, y equals mx plus b. Enter. oh, do you want to create sliders for M and B? It's kind of like the Desmos mentality, right? You create sliders, right? And so let's create the sliders now. And what happens is I change M. Well, M is, oh wow, that M affects how the line is tilted, huh? Interesting, yeah. So affect the tilt of the line. And what about the B value there? Oh, that kind of moves it up and down. I mean, kids aren't literally telling you that. They're not making the connection like, oh wow, that B value there is the same as that B value there. But I have an applet there that actually makes that slider blue, and I'll put the y-intercept as a big fat blue dot so they can better make the connection. You know what I mean? It's all on how you use the software. You can create stuff. You can feel free to download any of my stuff you want. It's totally, you can download the file, look behind the scenes, and you can change colors. You can do whatever, you can doctor it up, whatever the heck you want. That's what Open Education Resources is all about. It's free stuff. Take it and use it. I mean, like, I rarely look at a lesson or an applet and say, wow, but I might say, wow, that's cool, but if you can only do this, download it, I hit make a copy. I don't recreate it as my own because it's not fair to the original creator, but I'll hit make a copy and then it'll cite the original author and then my name is next to it because this is my version of this originally created thing. If that makes sense. Any questions about it? I know go ahead.
Yeah, I've shown this to math teachers in middle school all the time, and I always have to battle this. Well, they can't use this on any standardized test.
Okay, and
I would like to hear your response to that so I can go back and tell them that.
Well, on the standardized test, they have, what, is it like
TI, whatever.
The TI, whatever. So you know what, in my UConn AP Calc class, you know, I'll do stuff with, you know, polar coordinates and areas and stuff. Now, GeoGebra gives it 3D is such a beautiful way of seeing it, so I'll do it simultaneously with them. You know, now they can use the TI calculators on that, but the thing is that they should be able to use the TI. I mean, I know our high school doesn't require the TI until like honors pre-calc and then any kind of calculus they have after that. But in Algebra 2, I don't think it's technically a requirement. They have the scientific ones. But if they have, I think that should change personally, but if they have, now TI is great, but in terms of like speed and efficiency and like quality of the, you know, the pixelation, I mean, GeoGebra I think wins by far. To that I say, well, you know what? Our school, whenever you run out of graphing calculators, because the other teacher has them, GeoGebra just released an exam mode, basically, where it's kind of like, it's a lockdown browser, if you will, like NWA, right? What you can actually do is, like, you create a group. They have a groups feature, too, where, like, on Google Docs, you can collaborate. GeoGebra has a groups feature where you can actually, I'm working on a few projects with publishers and other agencies, so it's like you can share all your materials on one thing, and you can edit, you know, or view only, or whatever. But GeoGebra has their new exam mode, and so you can implement and start the exam, and the graphing calculator, like you see there, is up there. But if a kid tries to exit out and looks up on Google, their screen will turn bright red, and you'll get a notification instantly that, wow, the kid is breaching whatever. So, and it's free. You know, it's pretty cool. Stuff costs money, but the fact is, the fact that this is free is beautiful because now low-income districts that have internet connectivity, which a lot of them are through grants, monies, and stuff like that, they can have the same quality access to materials like this as, you know, kids in like a rich Greenwich town can have, you know. But it is tough. But you know, some of those teachers, it's like, and I'll have the same teacher say, "Oh, my kids buy a computer in the classroom, they go to other tabs and everything." But you know what? So it's like, it's all about classroom management. It's like not to insult you, but it's just, you know, if kids are excited to learn, when I say take out GeoGebra, oh, we're on GeoGebra again, yeah, like it's cool. But it's like there's teachers that avoid this like the plague, and I have there's people in my school that just kind of like, you know, avoid when GeoGebra comes up, they don't want to hear it. But it's going to happen no matter where you go. I mean, if you're excited about the technology and you love using it and you're passionate about it, your kids, because this will help your kids see the why. And if your kids can explain the why something is true, like stuff like this makes them tell you why, then the what and how to on standardized tests, I believe, will be second nature to them. Because, you know, any dummy can like slide a slider. I get that, but it's how you use it, it's how the teacher uses the applet that, you know, really, I think, makes the biggest difference in the world. I don't want to. Yeah. Any other questions at all, or? GeoGebra. GeoGebra. Yep. So. I have a business card here. Feel free to. I'm happy to share. You know, but I am during contract hours at school. I have to be at school, of course. But if I'm on a school vacation, we have different breaks or whatever like that. I mean, I'm happy to talk. You know, converse outside here if you want. But thank you very much for your time. It's a pleasure. Thanks.
So we won't report Tim back to Berlin High School. He was never here.
Oh, they don't.
I want to introduce our next speaker. Josiah is a good friend. this is not in his official bio, but he's one of the smartest, most reflective people that I know. Josiah started off as a science teacher, was department chair at Danbury High School for a number of years. From there went to the State Department of Education and finally landed at CREC, where he currently serves as the manager of educational technology, and also just recently started up a new venture within CREC, the Studio 111. It's application development, developing educational apps. So a great new venture, and Josiah's here to share some insights about the topic of gamification. So with that, I'll turn it over to Josiah.
All right, so I'm going to need a minute to pull up my presentation here. So while I'm doing that, quick show of hands, how many people have heard of gamification? Okay, great. That's kind of a trick question, right? It's in the title. How many people have participated in something that has been gamified? Okay. And how many people have implemented a system for gamification, like in their workplace or with their classrooms? Okay. All right, let me just get a quick poll. How many people are classroom teachers or maybe media specialists in a school? Okay. How many people are like technology directors or something along those lines, tech integration specialists? And then private industry? Did I miss a job type? Yes?
Library director?
Okay, excellent. Not at a school system?
No.
Excellent. Okay, great. All right, so let's dive in here. I almost never do PowerPoints except for when I'm asked to submit a PowerPoint. So I believe you'll be able to, they'll send this out to you or a version of this. And so I made it for you guys so you could take it with you. But I almost never make PowerPoints. So gamification, you see my quick definition up there, gamification. It's the idea of taking game mechanics or game elements, things that you would do in a game, and applying them to a system that isn't necessarily thought of as a game. Okay? So it doesn't mean necessarily that you're trying to make something fun, but that might be a byproduct of it. Okay? Because gamification at its core is really about changing the perception of motivation around some goal. Okay? And you do that in a couple ways. We'll dive deeper into the elements on this triangle here, but the idea is really to track performance, because if you think about games, well, basketball is happening right now. Any basketball fans? A couple? Okay. So if you look at basketball, you look at hockey, you look at football, any kind of game, whether it's a board game or whatever, right? What are the elements of a game? What are some of the parts of a game, so to speak? And we'll look at some of these in detail, but I just want to get a feel for it.
You have a challenge and then you have a reward.
Yeah, great. So a challenge and usually some kind of a reward. I think the reward can be very, very broad. There's a huge spectrum of what constitutes a reward, but definitely usually there's a reward. Yes?
Scoring.
Scoring, okay? So there's typically some kind of tracking of your performance right here, right? So tracking performance. Anybody else? Maybe one or two more? Yeah.
Rules.
Rules, definitely, right? So if we're going to say, hey, there's a reward at the end of this, there's a challenge, there are scores, there's points or something along those lines, well, how do you award those points, right? Usually there are rules, and if you want to be more broad, we'd say that there are constraints, right? So you can't just do everything you want, right? Basketball, you got to put this ball into the hoop, but you have to dribble when you walk. and you can't get a ladder and put it into the hoop. And there's a group of other people trying to keep you from putting that ball in the hoop, right? So you start to layer all these artificial constraints which make the game component, okay? Great. So we're going to be looking at eventually dynamics, which are the big picture aspects, like what are the things about games that make it motivational, and then we'll look at mechanisms. So we'll start to dive a little deeper and look a little more specific as to how do you set up those dynamics. And then we'll look at the components, so the actual almost nouns of the verbs that you have in the mechanisms. Okay? Just a quick visual example of some things that have been gamified. So I asked earlier how many people have participated in a gamified system. If you have a credit card, you have participated in a gamified system. Like I said, gamified systems don't necessarily have to be fun, right? But the idea of getting points, right? There are rules to being awarded those points. You go to the gas station, you get twice as many points as you normally would. You go shopping on a Wednesday while wearing blue pants, you get X amount of points. Whatever the rules are, you're getting points, and there's no other reason for you to get points other than to make it feel like you're being rewarded, right? So the idea of gamifying a system to motivate people, in this case with the credit cards here, is maybe a little insidious, but there's a lot. That just means, if you want to look for the silver lining, that just means that really smart people, psychologists and marketing people, have figured out that this stuff works, right? So if you want to use some of this stuff for, let's say, good in your workplace or with your students or your colleagues, that sort of thing, you definitely can. And so here are some good examples as well, right? We've got the idea of awarding badges. So we've got several badges from the Girl Scouts. We just had we were blessed by Girl Scout cookies recently. It goes so quickly, right? So this idea of the different categories that you can get badges in. If you've ever participated in martial arts, they award these effectively badges that you can wear around your waist, right? They're called belts. Okay, so those are quick examples, and so now that I show you that, how many people, let's ask that question again, how many people have participated in a system that's been gamified? Right? Pretty much everybody, unless you don't subscribe to any credit card. Okay. So let's talk about some of the specifics behind the motivation that you can get from adding games or gamified elements to some system. Okay? So when you have a game or game mechanics, oftentimes there's going to be an opportunity to master something. Okay? And so if I lay out the rules and you say, oh, well, I have to do X, Y, and Z, well, that's a challenge to me, right? We already said challenges are a part of games. So if I have a challenge, then it's a large part of the human psyche and condition to want to meet the conditions, if not all the conditions, certain conditions of a challenge. I know everybody, that's kind of a spectrum, right? Not everybody is interested equally in certain types of challenges, but that's the concept behind that. And I just put here, underneath that first bullet, good games build or transition to intrinsic motivation. Because at the end of this, we're talking right now, what are the motivational benefits? At the end of this, we're going to talk about what are some of the caveats that you have to be aware of? What are some of the concerns or potential pitfalls of gamifying the system? And so if you're not, big hint, if you're not transitioning to some kind of intrinsic motivation, you might actually demotivate your population. So we're going to talk about that a little bit. Okay? As far as how do we do that, a good piece of that, a good chunk of it, is by providing feedback. When you think of sports, what are some of the feedback that you would get if you're playing sports or if you're spectating sports? We already said one, right? Score. That's a big, obvious one. What's another piece of feedback that you might get? Cheering or clapping, right? The audience participation. They're getting excited. Yeah?
Penalty.
Penalty, right? So you broke the rules, you get immediate, quick feedback, right? So really what we're talking about is one of the things, like when you start to zoom out and just get philosophical about this stuff, one of the things about gamification is it's like real life. get feedback immediately, right? Because in the classroom, Doug mentioned I used to be a teacher, I could tell 9th grade students, oh, you're really going to want to know this stuff, but it's not going to impact your life, if I'm honest, until you're probably 29 or 30, right? I can't really lead a lesson with that. And that's why we have these points in school. Oh yeah, we have grades in school, right? Grades in school, you can look at it as a gamified system. If you went to school, you participated in a gamified system already, right? But how could you be more explicit and more thoughtful and deliberate about it? That's what we'll try to give you some ideas about, okay? So good games provide seemingly, not necessarily exactly, but they will seemingly feel individualized. Not saying every game can do this, or every gamified system can do this, but even if you're playing on a team sport, you have a certain performance expectation, right? So I was one of those weird kids that I played a quasi-team sport, right? I wrestled. So when you're wrestling, you're on the mat, it's just you and that other person you're wrestling. But you accumulate points for your team, right? And so even if you know this guy somehow is the same weight as me, but this person is in beast mode, and there's no way I can defeat this person and get him or her on his back, because we did have co-ed back then. If I can stay off my back, if I can lose the right way, I'm doing something for my team, right? And so individualized, but also team sport. So just a quick example of how you might get that. And learning is a natural part of games. And surprise, surprise, that's one of the main reasons why people like games. If you break it down into a psychological sense and you look at some of the research out there, people like games because they have to learn how to do something with these constraints. They have to understand how to have success with these rules. Okay? That's exciting to people. So learning, if you do it right, is a game. Not necessarily. No, there's several. I mean, if you go into digital games, there's several games that are me against the machine, right? But if you want to take it back into Stone Age times, if you could get a rubber ball, right? So you cut a tree in the middle of the jungle, you get the sap, you boil the sap down, you make a ball, right? I can take this ball and bounce it off the wall and catch it and see how many times I can do that. That's just me, the wall, and the ball. But it's a game because I've put constraints on myself, right? So anytime you have a goal and constraints, you effectively have a game. And that's what I'm trying to do. This is about awareness, right? So I'm glad you asked that question or you put that point to me. Because this is about awareness, right? How can you change your thinking to identify elements of a game that are already in place? And then, now that you know these elements and you have some introduction to them, how can you purposefully modify these elements and get results that you want to see? Okay, so when we talk about dynamic elements, I'm not going to go through every single one of these, but these, again, are the big picture elements, right? So what are the big picture things about games that we like so much? Already talked about the constraints, emotions. You sort of mentioned response from the audience, right? So that's even people who aren't even playing the game. They have an emotional response, right? So there's a lot of evidence that games can be really powerful. This one here in the middle, narrative, I'm going to emphasize that one because I think it's so very important. Sorry, I don't want to say it's critical, but if you can get narrative in there, it can be really, really powerful. And that's why I want to focus on it, because it's one of the elements that isn't necessarily worked up that much by beginners. Okay? So people who are masterful at this will institute or integrate narrative into it, right? You think about professional sportscasters. They're telling you where these athletes came from. They're telling you the challenges that they had to overcome to get to this stage and this level. They're building a story into it. Anybody like soccer? No? wrong audience? Maybe you heard about this because it kind of crossed over the oceans because it was such a monumental story. But this idea of Leicester City, the soccer team that last year in the Premier League was about to be relegated, they call it, kicked out of the league because they did so poorly. And from last year to this year, they actually won the league, right? That doesn't happen very often. It's a phenomenal story. It's narrative. So when you can build story into your games, it becomes really, really powerful stuff, really moving stuff. Progression, relationships, I think they're pretty straightforward. People need to feel like they're making progress. And how do they know they're making progress? If we go to some of the mechanisms, you got to give them feedback, right? Like I was saying, I'm kind of joking, but when I taught 9th graders, 13 and 14-year-olds, if they didn't get feedback about how they're doing, then they didn't care, right? It's not real until they get that feedback. Oh, what do you mean I'm failing, mister? Well, I tried to give you feedback in the form of, you know, this call to your mother, this detention about you not doing homework, whatever it is. So how do you give feedback to the players of your game, right? But here's some other mechanisms. So we already talked about challenges, choice. So classroom teachers, what would we call choice in the classroom? What does that fall under? DI? Differentiated instruction, right? That's a big element of differentiated instruction, giving people choice, okay? So you can either show me you understand this concept by doing this, or something else of your choosing, but you have to prove to me that it will meet my criteria, right? So just in that quick example, you can see how I'd start to introduce game mechanics into an ordinary lesson, okay? We have this idea of rewards right down there that was mentioned earlier, okay? Cooperation and competition. These can be both motivating and demotivating at the same time, two different people, right? And so now I'm starting to talk about some of these caveats. So competition, some people love competition. They love to see how they can do against each other. How many people like competition? Okay. Roughly 2/3 of the room raise their hands. How many people like cooperation a little bit better than competition, right? So maybe a team sport, or we're all doing well, right? So roughly 40% of the room right there. So 60-40, almost evenly split. I like a little bit of both, and so you can be on a spectrum, right? I just gave you my wrestling example, right? So back in the day, that's a little bit of both, right? It's me competing against somebody else, but cooperating, right? So if I know I can't beat this one person, how do I use the right way to give my team an opportunity to win? Okay? So those are some of the mechanisms out there, okay? Now we get into the components. What are the actual nouns of those elements? Like, how do I give people feedback? What are the things I can use to give people feedback? What are the things that I can use to make people feel that they're having progress? What are the things that I can do to help people understand how they're doing competitively or cooperatively, right? And so you take a look at these. Some of them are pretty obvious or self-explanatory as soon as you see the words behind them, right? Points, badges, leaderboards. We already saw badges with the Girl Scouts or the karate belts or taekwondo belts. Points, several games that you've played or experienced in your lifetime have points. I already said, school has points, right? Okay, boss fights. This is starting to dig into the weeds a little bit, more of my geek culture coming out, right? So a boss fight is a big summative application of your skill, if I turn it into teacher speak or educator speak. So what might be a boss fight outside of a video game, right? In a video game, boss fight is literally like this character that covers, half the screen, and you're this tiny little guy, and you have to defeat that character somehow, right? That's a stereotypical boss fight. But in real life, what is a boss fight?
Unit tests.
Unit tests.
Any kind of assessment that's going to sum up. Okay,
definitely. Unit tests in schools, but not even necessarily in schools. What's a boss fight? Hopefully you're not punching your boss. That's not what I mean. Boss fight. I'll give you an example. Preparing for this. This is kind of a boss fight, right? I have to prove that I understand all this stuff about gamification and deliver it to people most of you I've never seen, and that's actually a challenge for me, because as much as I speak in public, I hate it. I always get the shakes and everything like that, and so it's not something I enjoy, so this is a boss fight for me, right? I'll be giving another big presentation to literally my boss and her boss on May 18th. That's a boss fight, right? So any kind of summative project you've been working towards, fill in the blank, for this much time, that's potentially a boss fight. And so now you can, now that you've identified this, you can go back and gamify it, right? So how could I have gamified preparing for this boss fight? What are some things that I could have done? Yeah?
Research.
Okay, so I could research, but how does that fit into one of these components or some of the dynamics or mechanisms that we looked at before? So the goal is to present here, right? How do I motivate myself to be prepared and to present here? Create a schedule, okay? Practice, okay? And when I practice, maybe I should get feedback. So that means I need to practice in front of somebody else, or I'm practicing against some constraint, right? I knew that I had roughly 20 minutes to present and roughly 10 minutes to get questions, so that's a constraint. So I can start practicing in front of a mirror with the timer, and when I get that, when I hit my mark, maybe I get a reward, a cookie or ice cream or something, right? Or I just feel good about myself, right? So whatever, maybe this sounds familiar. Maybe this is how you got through certain classes in college. Maybe this is how you kept the peace between you and your mother, and you figured out that I need to actually clean my room sometimes, right? Right? So maybe that's how your mom got you to clean your room. Whatever it is, I'm sure you can start to, now that we know explicitly some of these components in gamification, hopefully you can start to identify instances in your life where things were gamified, right? Because the next step would be to think about how you can apply this to work situations or scenarios, time with students, that sort of thing. Okay? So I'm sure you're going to hear this many, many more times today. 30 minutes is not enough time, right? You already heard it once, and I'm repeating it. Typically, I do this as an intro in about 3 hours, and we have a lot more examples. We have time for people to actually apply and build their own systems and then share and get feedback on them. Oh, feedback, right? That's good. So, and typically I would try to actually gamify the instruction itself. So I'm modeling what you could be applying yourself. But obviously the constraints are too much. So my goal really was just to not talk to you after 11:30, because that's what I was asking you, right? So limitations, I already hinted at some of these, and precautions, right? So we've all heard this saying, you can game the system, right? So if I'm gamifying a system and somebody games my gamification, what does that mean?
They're exploiting weaknesses.
Yeah, exactly. They're exploiting it, right? So I gamified it to move them, motivate them towards a certain goal, and they are finding a way to use the rules that I have. They're finding loopholes. They're natural lawyers, and they're finding those loopholes and saying, oh, that's all I got to do? Done. Doesn't mean they learned or gained the knowledge that I needed to impart, but technically they met the criteria of my game, right? So that's always a risk, and so you want to be flexible. And so sometimes you just need to be able to say, well, it's my game, I changed the rules, right? Hopefully you can find a more tactful way of saying that, especially if you're dealing with kids, because kids respond to fairness. But sometimes you have to acknowledge that, yeah, somebody might game your system, and you need to be responsive and flexible to them. Okay? So an overemphasis on the game can lead to backlash. What I mean by that is, I already gave an example. Some people like competition, some people don't. So if I'm only using competition in my gamified system, some people are going to be turned off. And there's a lot of research, and as soon as I say this, it's going to make perfect sense to most of us, right? But there's research that says that people in the bottom quartile, or sometimes the bottom 50% of that leaderboard, when they see that they're in the bottom, guess what? They give up, right? So in that case, if all I'm doing is using points in a leaderboard, and I'm showing, hey kids, you have no chance of making this goal, then the logical thing for them is to quit, right? So that's a concern. You have to be careful. How do you balance the mechanics that you're implementing to make sure that the majority, if not everybody, in the system is motivated? And it might even mean that you have an opt-out system. Okay? And then failure to transition to intrinsic values. There's lots of psychological research that says when you reward people for things they're expected to do, that's part of their quote-unquote job. So whether you're dealing with adults or whether you're dealing with students, when you consistently reward people for things they're supposed to do, then they stop doing them unless they get the reward. And after a while, with many people, the reward will not even work. Okay? So that's a concern. You have to be very targeted and deliberate about what you're rewarding, and you probably want to have a time limit to that. Okay? For this stretch of this project, we're all going to double down, and because of that, here's this reward system. But it's normally part of our job to do this stuff anyway. This is just a critical time, so we're going to double down and do this, right? So you translate that to schools. Right now is the AP testing time, right? Our speaker in the morning, just before me, he's a calculus teacher doing AP, right? So you might say for that AP session, for the month of May and probably a little bit of April, there's a reward system. But normally, you just need to do your homework, right? That's an expectation lesson. Okay? So those are things that you need to be careful about, you need to think about when you start to implement this. So obviously, that was a very quick crash course on an introduction to gamification. How do you get more information and what are some of the references that I use? So this Coursera, how many people have heard of Coursera or maybe MIT edX or a MOOC, massively open online course, right? So these are online courses, typically free, and sometimes there might be a cost, but those costs really lead to certification. But if you don't want certification, it's completely free. So if you do a Google search for gamification, Kevin Warbach, or Coursera gamification, you'll find this course, and you'll see a lot of the concepts that I just talked about deeply explained. It's about I think it was like a 9 or 10-week course, and he goes deep into it. He is a professor at the university, associate professor at the University of Pennsylvania, and he's in the School of Business. So he definitely talks about it from the business aspect, dealing with adults, less of education. But you can definitely turn it into what you need. And then the last piece here, CREC Summer Institute. So we'll be doing a 3-day workshop on gamification, where we'll have lots of hands-on application and trial. We have a teacher who's been doing this in her classroom for the last 4 or 5 years. She'll come in on the second day and give some examples, and we'll help teachers build units or lessons around this stuff. So if you're interested in that, you can go to www.crec.org, crec.org/summer. And I also have some flyers if you're interested that have a list of all the workshops we'll be doing, but specifically we have one on gamification in the middle of July. Okay. I appreciate your time and audience participation. I'll stick around outside if you have any other questions, but I think we're out of time. Thank you.
Thanks for attending. I think lunch is getting served up and you can hang out and talk to Josiah if you like, have questions. Thanks for coming.
Anybody with a flyer? We've got them up here.